Hey guys, tonight we are going on what is possibly the most uneventful, most drawn out, and frankly, the most boring road trip in the known universe. We're going to experience the extremely long and dull commute of a comet from the Oort Cloud. So, find your coziest spot, maybe fluff up your pillow, and remember to put on your thickest conceptual spacesuit. It's really, really cold out there, and the journey is so long, you'll definitely fall asleep before we even get halfway. Which is, of course, the whole point. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. While you're at it, drop a comment and let me know what city you're listening from and what time it is for you. It's always fascinating to see our little community of night owls scattered across the globe, all settling in for a shared cosmic drift. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. Your existence begins not with a bang, but with a stillness so profound it feels like the universe is holding its breath. There is no before for you, just this moment. You are here. But here is a concept that barely has any meaning. You are floating in the Oort Cloud, the vast, frigid, and almost mythical outer suburb of the solar system. Forget everything you know about clouds. This isn't a fluffy white thing in a blue sky. This is a sparse, spherical shell of trillions upon trillions of icy bodies, surrounding the sun at a distance so immense it's hard to comprehend. Imagine you're a single grain of sand on a beach that stretches for thousands of miles in every direction. Now, imagine your nearest neighbor, another grain of sand, is 100 miles away. That's the kind of lonely we're talking about. It's less of a cloud, more of a cosmic social distancing champion. You are one of those icy bodies. Right now, you're not a magnificent, glowing comet with a tail. You're just a lump. A few kilometers across, misshapen, and deeply unimpressive. You are a dirty snowball, as one clever human astronomer would one day call your kind. A frozen cocktail of water, methane, ammonia, carbon dioxide, and a generous sprinkling of dust and rock, all held together in a deep, deep freeze. The temperature here hovers just a few degrees above absolute zero, the point at which all atomic motion nearly ceases. At this temperature, the atoms that make you up are vibrating so slowly, they're practically in a state of cryogenic meditation. It's a stillness that has lasted for billions of years. The sun, the star you technically orbit, is just a star from here. Not the brilliant, life-giving orbit is for the inner planets, but simply the brightest pinprick of light in a sea of countless others. It offers no warmth, no comfort, just a weak gravitational tether that barely keeps you from drifting off into interstellar space entirely. And for 4.5 billion years, this has been your life. A slow, lazy, unimaginably long orbit around this distant star, taking tens of thousands, maybe even millions of years to complete one lap. Nothing ever happens. Until today. It's not a violent shove. It's not a dramatic explosion. It's more like a cosmic sigh. A few million years ago, a star, a complete stranger, wandered a little too close to your neighborhood on its own journey through the galaxy. Its gravitational whisper, a gentle ripple through the fabric of space, was just enough to nudge your orbit. Ever so slightly. It was a change so minuscule that for thousands of years, it meant nothing. But orbital mechanics is a game of patience. That tiny nudge has been compounding, cycle after cycle, until this very moment. You feel a subtle, almost imperceptible shift. Your impossibly slow orbit has been perturbed just enough. You've been knocked off your stable, boring path and onto a new one. A long, decaying ellipse that is now aimed, like a slow-motion arrow, directly toward that bright star in the distance. You have begun to fall toward the sun. This place you're leaving, the Oort Cloud, is one of the solar system's great theoretical triumphs. No one's ever seen it with a telescope, not really. It's too far, too faint, too sparse. It was proposed by an astronomer named Jan Oort to explain why new comets keep showing up in the inner solar system from all possible directions. And this is where it gets a bit fuzzy, even for the smartest folks on that little blue dot you'll eventually fly past. Astronomers are still debating the exact shape and origin of this cloud. Is it a perfect sphere, or is it a bit squashed, like a weird cosmic egg? Did its contents, like you, form way out here in the cold, or were you all flung out from the inner solar system during its chaotic, planet-forming childhood? The evidence is scattered, and the arguments are passionate, whispered across conference rooms and academic papers. For you, though, these debates mean nothing. All you know is the new, undeniable sensation of movement. Your new velocity is pathetic. We're talking walking pace. Maybe even slower. A few meters per second. But here's the thing about space, give it enough time, and even a snail's pace can cross an ocean. And you have all the time in the universe. Your journey has begun. A commute that will take you more than 1,000,000 years to complete, one way. For now, nothing changes. The stars in the distance are static points of light. They don't twinkle, there's no atmosphere to disturb their gaze. They are cold, sharp, and unforgivingly distant. The only thing that tells you you're moving is a slowly, impossibly slowly, shifting perspective against the backdrop of the Milky Way. You are leaving the only home you've ever known, on a one-way trip toward a fire you can't yet feel. Your journey is defined not by what you see, but by what you don't. For the first few 100,000 years, absolutely nothing changes. Imagine being on a highway, but the road is perfectly straight, the landscape is a uniform, featureless black, and the destination sign simply reads, eventually. You don't have a dashboard clock, but if you did, you'd watch the centuries tick by like seconds. 10,000 years. 50,000 years. 100,000 years pass, and the only perceptible difference is that the sun, that one special star, has become just a little bit brighter. It's gone from being the brightest star to the noticeably brighter than all the other stars star. A subtle promotion, but a promotion nonetheless. You are gaining speed, of course. Gravity is a patient and persistent force. What started as a gentle nudge is now a constant, unrelenting pull. You're in a perpetual state of falling. But space is so big, so mind-bogglingly empty, that even as your speed increases from a walking pace to a running pace, and then to the speed of a bullet train, your progress feels comically slow. The distances are just that obscene. It's the ultimate cosmic joke. Are we there yet? Asked the comet. The universe just stares back, silently, for another 10,000 years. Here, on this lonely stretch of space-time, the most common unit of measurement used by those little intelligent beings on that dot you're heading towards becomes relevant, the astronomical unit, or AU. It's the distance from their home planet, Earth, to the Sun. A neat 150 million kilometers. It's a vast distance for them, but for you, it's just a single-mile marker on an infinite road. In the time it takes for entire civilizations to rise and fall on that distant blue world, you might cross a few dozen of these AUs. Your progress is measured in the geological ages of other worlds. You are a creature of pure patience. You don't get bored. You don't get restless. You just are. Floating, falling, and being. The view, however, is spectacular in its monotony. Ahead, the growing fire of the sun. Behind, the fading memory of your cold, sparse home. And all around you, the majestic, silent river of the Milky Way. From your vantage point, far above the galactic plane, you can see the whole structure, the swirling arms, the glowing central bulge, a city of 100 billion stars that you are now falling toward. It's a sight of such profound beauty that it would break the heart of any poet, but to you, it's just the wallpaper. It's always been there. It never changes. Well, almost never. While the stars seem fixed, the space between them is not as empty as it looks. It's fizzing with invisible particles. You are constantly being pierced by cosmic rays, high-energy protons and atomic nuclei shot out from distant supernovae, galactic events that occurred millions of years ago, whose shrapnel is only now reaching you. These particles zip through you at nearly the speed of light. They pass straight through your icy body as if you weren't there, leaving no trace. And here's a funny little fact about these cosmic bullets: on the technologically advanced worlds you're approaching, these same particles are a real nuisance. They can strike a microchip and flip a 1 to a 0, causing a computer to glitch or a satellite to malfunction. But your simple, frozen, non-digital consciousness is gloriously immune to this headache. You are, in essence, technologically unhackable. A rock-solid, low-tech traveler in a high-energy universe. After what feels like an eternity, let's call it 1,000,000 years, give or take a few millennia, you cross an invisible boundary. It's called the heliopause. This is the true edge of the sun's influence, where the solar wind, the stream of charged particles flowing from the sun, finally peters out and collides with the interstellar medium. You have officially left interstellar space and entered the sun's house. You've crossed the threshold. It's not a wall, it's more like stepping from a still room into one with a very, very faint breeze at your back. You are now inside the heliosphere, the giant magnetic bubble carved out by the sun in the galactic medium. And this bubble is a place of great scientific argument. For the longest time, astronomers debated its exact shape, wondering if it was a perfect sphere or teardrop-shaped, with a long tail stretching out behind it as the solar system moves through the galaxy. Data from 2 plucky little human spacecraft, the Voyagers, which crossed this boundary decades ago, have helped, but the debate continues. Is the boundary smooth, or is it frothy and turbulent? Is there a wall of hydrogen piled up just outside? You sail right through the middle of this cosmic squabble, completely oblivious. For you, the only change is a subtle shift in the unseen energies around you. The sun is now clearly a star apart. It's no longer a point of light, it's a tiny, brilliant disk. And for the first time in your long existence, you start to see other, fainter lights that aren't stars. They shine with a steady, reflected glow. One in particular, a tiny, deep blue pinprick, is slowly growing larger in your path. It doesn't belong to the fixed background of stars. It's moving. It's a planet. Your long, lonely journey across the empty highway is finally over. You're approaching the suburbs. That little blue pinprick is your first real landmark in over 1,000,000 years. As you draw closer over the next few thousand years, a mere blink of an eye in your travel log, it resolves into a breathtaking, deep blue sphere. This is Neptune, the first of the ice giants, the outermost guardian of the planetary realm. It's your official welcome to the solar system proper. The sign on the cosmic highway might as well read, "Now entering solar system. Please drive carefully. Speed limit, 30 kilometers per second and accelerating." You feel a slight gravitational tug from it, a gentle curiosity from this enormous world. Neptune is a beast, 17 times the mass of that little blue-white marble you'll meet later. It's a giant ball of swirling, frigid gas. Its surface, or what passes for a surface, is a maelstrom of the fastest winds in the solar system, screaming at over 2,000 kilometers per hour. That's faster than the speed of sound on Earth. From your silent, vacuum-wrapped perspective, you can't hear the fury, but you can see it. Faint, dark storm spots, like bruises on its azure skin, drift across its face. It's a world of incredible violence, all wrapped in a serene, beautiful package. Its blue color, by the way, comes from methane in its upper atmosphere, which absorbs red light from the sun and reflects blue light back into space. It's the same reason Earth's sky is blue, just with a different chemical culprit. A nice little bit of parallel cosmic chemistry. You glide past it at a safe distance. Your trajectory, dictated by the sun's overwhelming pull, barely registers Neptune's presence. But you're close enough to see its family of moons. The largest one, Triton, is a particularly weird character. It's almost as big as Earth's moon, and it orbits Neptune backwards, against the direction of the planet's spin. This is a huge red flag in orbital mechanics. It strongly suggests Triton isn't a homegrown moon but a captured wanderer from the Kuiper Belt, a region you just spent a long time traversing yourself. It's like seeing a distant cousin who took a wrong turn at Albuquerque and ended up in a very strange, codependent relationship. Triton is also geologically active, with geysers of nitrogen frost erupting from its surface. A frozen moon with ice volcanoes. The solar system is already getting weird. Your journey continues inward. The next landmark on your tour is Neptune's near twin, Uranus. It takes you centuries, maybe even a millennium or two, to cross the gap between them. From a distance, Uranus looks like Neptune's paler, less interesting sibling. It's a hazy, almost featureless ball of pale cyan. Its tranquil appearance is deceptive. It's another ice giant, mostly composed of water, methane, and ammonia ices above a rocky core. And this is a good place to mention a fun fact: these aren't ice giants because they're covered in ice like you are. They're called that because their bulk composition is made of these heavier, icy materials, unlike the gas giants Jupiter and Saturn, which are almost entirely hydrogen and helium. So, they're more like giant, slushy, high-pressure snow cones than solid ice worlds. The truly bizarre thing about Uranus isn't its color or composition, though. It's its orientation. The planet is tipped over on its side. Its axis of rotation is tilted by about 98 degrees relative to its orbit. So, while other planets spin like tops as they orbit the Sun, Uranus rolls like a ball. This results in the most extreme seasons in the solar system. For a quarter of its 84-year orbit, one pole faces the Sun constantly while the other is in total darkness. Then, for the next quarter, they switch. It's a planet that seems to have suffered some kind of catastrophic cosmic punch in its distant past, knocking it clean over. And that's one of the great unsolved mysteries of planetary science. What knocked Uranus over? Was it a single, massive impact with an Earth-sized protoplanet during the chaotic early days of the solar system? Or was it a series of smaller shoves from other large bodies? Or perhaps it was a strange gravitational resonance with a large moon that was later ejected. Scientists have run countless simulations, but the jury is still very much out. It's a cold case, billions of years old. You fly past this cosmic crime scene, an indifferent witness, feeling its gravity tug at you ever so slightly, a silent participant in the ongoing celestial dance. As you leave the ice giants behind, you can feel a distinct change. The Sun is no longer just a bright star, it's a small, dazzlingly brilliant disk. And for the first time in your entire existence, you begin to feel its warmth. It's not much, just a faint tickle on your frozen surface. The temperature rises from a frigid 30 Kelvin to a slightly less frigid 40 or 50 Kelvin. It's not enough to melt anything, not yet, but it's enough to stir something deep within you. The most volatile of your frozen gases, substances like nitrogen and carbon monoxide, are beginning to feel restless. The atoms on your surface, so still for so long, are vibrating with a newfound energy. You are now entering the realm of the giants. The space ahead is dominated by the next two planets on your itinerary, and they are in a league of their own. Your long, cold, and boring commute is about to get a lot more interesting. The quiet suburbs are behind you. You're approaching the bustling downtown core of the solar system. After cruising past the weird, sideways world of Uranus, you spend the next few centuries, a trivial amount of time for you, crossing another vast, empty gulf of space. The sun is growing noticeably now, a brilliant pearl against black velvet, and its warmth is becoming more insistent. That gentle tickle on your surface is turning into a persistent, low-grade fever. Your outermost layers are starting to get fidgety. Then, you see it. At first, it's just a yellowish point of light, but it grows with astonishing speed. This is Saturn, the jewel of the solar system. And jewel isn't just a poetic flourish, it's the only word that truly fits. As you get closer, it resolves into a creamy, butterscotch-colored sphere, crossed by subtle, parallel bands of clouds. But the planet itself, magnificent as it is utterly upstaged by its accessories. The rings. Oh, the rings. They are impossibly thin and breathtakingly wide. From your angle of approach, you see them as a shimmering, luminous disk that encircles the planet, tilted toward you like a giant celestial halo. They stretch for hundreds of thousands of kilometers, yet in most places, they are only a few tens of meters thick. If you were to scale the rings down to the size of a football field, they would be thinner than a sheet of paper. It's a structure of ludicrous proportions, a masterpiece of gravitational engineering. You watch, mesmerized, as you drift closer. The rings aren't solid. They are composed of billions upon billions of individual particles, ranging in size from tiny dust specks to chunks as large as a house. And almost all of them are made of water ice. They are, in essence, a flattened, orbiting blizzard of countless tiny snowballs. This is why they are so bright, they reflect sunlight with incredible efficiency. You are a dirty, lumpy snowball yourself, but these are pristine, sparkling, and organized. You feel a strange sense of kinship, like a grubby country cousin visiting their impossibly glamorous city relatives. You see gaps in the rings, dark lanes carved out by the gravitational influence of Saturn's many moons. The most famous is the Cassini division, a wide gap easily visible from Earth's telescopes. But up close, you see that the whole system is a complex tapestry of thousands of smaller ringlets and gaps, like the grooves on a vinyl record. Tiny shepherd moons patrol the edges of some rings, their gravity hurting the ice particles and keeping them in line. It's a delicate, intricate dance of ice and gravity, all orchestrated by the immense presence of Saturn itself. You glide over the top of the ring plane, a safe distance away. Getting caught in that celestial buzzsaw is not on your itinerary. From this vantage point, you can see the shadow of the rings cast upon the planet's northern hemisphere, a dark, curving stripe that adds to the scene's three-dimensional grandeur. Saturn itself is a fascinating world, a gas giant even larger than the ice giants you've already passed. It's the least dense planet in the solar system. Here's the classic science tidbit: if you could find a bathtub big enough, Saturn would float. Its main components are hydrogen and helium, the lightest elements in the universe. But deep within its core, the pressures are so immense that hydrogen is squeezed into a liquid, and then into a metallic state, a bizarre substance that conducts electricity and generates Saturn's powerful magnetic field. However, the exact nature of Saturn's core remains a subject of intense scientific debate. Does it have a solid, rocky core like Jupiter is thought to have? Or is it more of a fuzzy core, a gradual transition of heavier elements mixing with the metallic hydrogen? The data from the Cassini spacecraft, which orbited Saturn for years, is still being analyzed, and planetary scientists are fiercely divided on the interpretation. As you pass, you also get a glimpse of its staggering collection of moons. Over 80 have been confirmed so far, and the count keeps rising. They are a diverse bunch of worlds. There's Titan, the second largest moon in the solar system, even bigger than the planet Mercury. It's wrapped in a thick, smoggy, orange atmosphere, the only moon known to have one. It has rivers, lakes, and seas, but they are filled with liquid methane and ethane, not water. Then there's tiny Enceladus, a bright white ball of ice that shoots enormous plumes of water vapor into space from tiger stripes near its south pole. These plumes contain organic molecules, making Enceladus one of the most promising places to search for extraterrestrial life. You pass them all, a silent tourist observing these strange and wonderful little worlds from afar. The sun's warmth is now undeniable. Your surface temperature has climbed to over 100 Kelvin, minus 173 Celsius. It's still bone-chillingly cold, but it's warm enough for the most volatile ices on your surface to start sublimating, turning directly from a solid into a gas. A very thin, almost invisible atmosphere begins to form around your lumpy body. This is called the coma. It's a fuzzy, glowing shroud of gas and dust. You are beginning to transform. The boring, inert ice rock is starting to wake up. You're no longer just falling, you're actively participating in your journey. Your long, dull commute is finally entering its scenic phase. And up ahead, looming like a giant, striped guardian, is the undisputed king of the planets. Leaving Saturn and its ethereal rings in your rear view, you are now squarely in the gravitational territory of the biggest player in the solar system, aside from the Sun itself. This is Jupiter, the king of planets, a world so massive it could swallow every other planet whole and still have room to spare. Its gravity is a palpable force, a deep well in spacetime that you are now tumbling into. Your path warps, bending noticeably as you approach. This isn't a gentle nudge like you felt from the other planets, this is a firm, commanding shove. Jupiter is immense. It fills your view. It's not a planet, it's a universe of its own. A colossal ball of gas and liquid, striped in swirling bands of cream, orange, brown, and white. These bands are zones of rising and falling gases, flowing in opposite directions at hundreds of kilometers per hour. The borders where these jet streams meet are scenes of unimaginable turbulence, creating swirls, eddies, and storms that could dwarf the entire Earth. And then there's the Great Red Spot. You see it clearly, an ancient, furious hurricane that has been raging for at least 400 years. It's a storm wider than our own planet, a permanent vortex of such scale and power that it defies easy explanation. To you, a silent observer, it's a mesmerizing, slowly churning eye, the focal point of all the chaos on the planet's surface. It's the kind of landmark that makes you feel appropriately small and insignificant, which, in the grand scheme of the cosmos, is a pretty accurate feeling. As a gas giant, Jupiter has no solid surface to land on. If you were to plunge into its atmosphere, you would just descend through ever denser layers of gas, the pressure and temperature rising to insane levels until you were simply crushed and vaporized. It's a classic example of a gas giant, composed primarily of hydrogen and helium, just like Saturn and the Sun deep inside. The immense pressure is believed to squeeze hydrogen into a liquid metallic state, creating the most powerful magnetic field of any planet in the solar system, a fact that leads to one of its most spectacular and lesser-known features. You can't see it with your own eyes, but if you could perceive magnetic fields and radio waves, you'd be blinded. Jupiter's magnetic field is a monstrous bubble that extends millions of kilometers into space, trapping charged particles from the solar wind. These particles are funneled down toward the planet's poles, where they slam into the atmosphere and create auroras, just like the northern and southern lights on Earth. But Jupiter's auroras are thousands of times more powerful and are permanent. They are also invisible to the naked eye, glowing primarily in ultraviolet and X-ray light. It's a constant, silent, and outrageously energetic light show, a secret rave happening at the top and bottom of the world that you're just drifting past. Your trajectory takes you close enough to feel Jupiter's influence but far enough to avoid being captured into a new, permanent orbit around it. Many of your cometary brethren haven't been so lucky. Jupiter acts as the solar system's bouncer or, perhaps more accurately, its gravitational vacuum cleaner. Its immense gravity has captured countless comets and asteroids over the eons, either flinging them into new, safer orbits or pulling them in for a final, spectacular death dive. In 1994, humans watched in awe as a comet named Shoemaker-Levy 9, which had been torn apart by Jupiter's gravity on a previous pass, slammed into the planet piece by piece, leaving dark scars in the cloud tops that lingered for months. You are lucky. Your angle is right, your speed is just enough. You are just a visitor, not a sacrifice. As you swing by, you get a front-row seat to the Galilean moons, Jupiter's 4 largest satellites, discovered by Galileo Galilei in 1610. They are worlds in their own right. There's Io, the closest, a volcanic hellscape. It is the most geologically active body in the solar system, constantly racked by Jupiter's tidal forces, which flex and heat its interior, causing hundreds of volcanoes to spew sulfurous plumes into space. It looks like a moldy, cosmic pizza. Next out is Europa, a smooth, white world covered in a shell of water ice. But beneath that ice, the same tidal heating is thought to maintain a vast, global ocean of liquid water. An ocean that might contain twice as much water as all of Earth's oceans combined, and one of the top candidates for harboring life beyond Earth. Then there is Ganymede, the largest moon in the entire solar system, bigger even than the planet Mercury. It's a complex world of dark, ancient, cratered terrain and younger, brighter, grooved terrain. It's the only moon known to have its own magnetic field. And finally, there's Callisto, the outermost of the 4, a heavily cratered, ancient, and geologically dead world. It's basically a cosmic museum piece, its surface recording billions of years of impacts. Jupiter and its family of moons are a miniature solar system, a perfect demonstration of how planetary systems form and evolve. But you have no time to linger. The giant planet's gravity acts like a slingshot. As you fall toward it, you gain speed, and as you fly away, you don't lose all of it. You are flung forward, faster than ever before, deeper into the solar system. The warmth of the sun is now becoming a serious presence. Your coma, that fuzzy atmosphere of gas and dust, is expanding, growing brighter. You are starting to look less like a lumpy rock and more like a proper comet. Your journey through the realm of the giants is over. Up next is a long, dark stretch of road, but this one isn't empty. It's littered with rubble. After being unceremoniously flung away by Jupiter's gravitational slingshot, you are now hurtling inwards at a respectable clip. The sun is a genuinely brilliant, hot star in your sky, and the warmth is no longer a gentle suggestion, it's a command. Your surface is actively fizzing, a constant process of sublimation that sheds gas and dust into the vacuum around you. Your coma has grown into a vast, glowing sphere, hundreds of thousands of kilometers across, though it's still incredibly tenuous. You are becoming a spectacle. Ahead of you lies a region of space famous in science fiction, a place that conjures images of daring spaceship chases and perilous navigation. This is the main asteroid belt, a vast, donut-shaped ring of rocky debris orbiting the Sun between Jupiter and Mars. The name, belt, is, frankly, a bit of an exaggeration. It sounds like a dense, cosmic gravel pit you have to dodge and weave through. The reality, as is often the case in space, is much bigger and much, much emptier. You plunge into the belt. And, nothing happens. You see a few more points of light that aren't stars, but they are incredibly far away. One might pass within 1,000,000 kilometers, which in cosmic terms is a near miss, but to you, it's just another distant neighbor you wave at as you speed past. The average distance between asteroids and the main belt is over 1,000,000 kilometers. If you were standing on one asteroid, you would be extremely lucky to see another one as anything more than a faint, star-like point. Space is just that big. So, all those movie scenes with ships banking hard to avoid a dense field of colliding rocks? Pure fantasy. The asteroid belt is more like a vast, three-dimensional desert sprinkled with a few million rocks, most of them quite small. These rocks are the leftovers from the formation of the solar system. They are the cosmic rubble, the bricks and mortar that never quite managed to build a planet. Why? One big reason is the bully you just passed, Jupiter. Its enormous gravity constantly stirred up this region, giving the planetesimals, the small, burly building blocks of planets, too much orbital energy. Instead of gently bumping into each other and sticking together to form a larger body, they collided at high speeds, shattering each other into smaller pieces. This cosmic construction project was doomed from the start, thanks to its overbearing neighbor. As you drift through, you see the variety of this failed planet. Most of the asteroids are C-type, or carbonaceous, meaning they are very dark, rich in carbon, and chemically primitive, not unlike you, actually. They are relics from the outer parts of the belt, ancient and largely unchanged since the dawn of the solar system. Then there are the S-type, or silicaceous, asteroids, which are brighter, made of stony materials, and more common in the inner part of the belt. And sprinkled among them are the rare M-type asteroids, which are thought to be the exposed metallic cores of larger planetesimals that were shattered in ancient collisions. You pass by a particularly large one. It's not a sphere, but a lumpy, potato-shaped rock a couple of 100 kilometers across. This is one of the larger inhabitants of the belt, but it's still just a minor player. The undisputed king of the asteroid belt is Ceres, which is so large, almost 1,000 kilometers in diameter, that its own gravity has pulled it into a nearly perfect spherical shape. It's big enough to be classified as a dwarf planet, the only one in the inner solar system. It's a fascinating world with mysterious bright spots on its surface, now known to be salt deposits left behind by sublimating ice from beneath its crust. It hints that even these old rocks can have complex geology. You, a visitor from the far-flung Oort Cloud, are chemically very different from most of what you're seeing here. You are much richer in volatile ices, frozen water, ammonia, methane. The asteroids are primarily rock and metal, having formed in a warmer part of the solar system where these ices couldn't easily condense. This chemical difference is a key clue for those little beings on the blue planet, helping them distinguish between comets like you and asteroids. Although, to make things confusing, the line between comet and asteroid is becoming increasingly blurry for scientists. They've found active asteroids in the belt that sometimes sprout tails like a comet, probably due to ice buried beneath their surface getting exposed and sublimating. And they've found comets that have run out of gas, so to speak, and now look just like inert asteroids. The universe, it seems, isn't a big fan of neat and tidy labels. Your passage through the asteroid belt takes a few years. It's an uneventful crossing, a long drive through a very sparsely populated historical district. But it's a significant milestone. You have now officially crossed the frost line, the orbital distance from the sun beyond which it's cold enough for water ice to remain stable. Inside this line, in the region you are now entering, the sun's energy is too intense for exposed ice to last for long. This is the domain of the rocky planets, the inner solar system. The sun is now a formidable presence. It's a searing, white-hot disk in the sky, and its radiation pressure, the physical push of sunlight itself, is starting to affect you. The gas and dust boiling off your surface are being pushed away from the sun, forming the beginnings of a tail. You now have two of them, in fact. One is the dust tail, a broad, curved, and yellowish-white trail of small solid particles left behind in your orbital path, like breadcrumbs. The other is the ion tail, a fainter, straighter, and bluish tail made of ionized gas that is pushed directly away from the sun by the solar wind. You are finally starting to look the part. You are no longer a dirty snowball or a fuzzy lump. You are a true, spectacular comet, a celestial visitor with a glorious banner announcing your arrival. And the inner planets are waiting. Leaving the cosmic rubble of the asteroid belt behind, you are now officially in the warm, well-lit, and comparatively crowded downtown of the solar system. The sun is no longer just a source of light and heat, it's a roaring furnace that dictates your every move and your very form. Your two tails, the dust and the ion, now stretch for millions of kilometers behind you, a glorious, temporary appendage that makes you one of the most beautiful sights in the sky. You are a cosmic celebrity making your grand entrance, and the inner planets are your audience. The first of these warm neighbors you encounter is Mars. The red planet. It's a small, dusty, and cold desert world. From your perspective, it's a striking ochre-colored globe with distinct white polar ice caps and darker, rust-colored plains. You can make out the faint outlines of giant, dormant volcanoes and vast canyon systems, scars from a more geologically active past. Mars is a world caught between states. It's not as dead as the Moon, but not nearly as alive as the next planet on your tour. Mars is a world of thin atmosphere and faded glory. Billions of years ago, it was a warmer, wetter place with a thick atmosphere, flowing rivers, and perhaps even a shallow ocean. But it lost its global magnetic field, and over time, the solar wind stripped away most of its atmosphere, leaving it the cold, arid world it is today. As you sweep past, you are a poignant reminder of what Mars has lost. You are a ball of frozen water and organic compounds, the very ingredients for life that Mars once had in abundance but can no longer hold on to. You might even shed a few dust particles into its thin atmosphere, a tiny, fleeting gift from the outer darkness. On its surface, several robotic emissaries from the next planet over are diligently scouring the dust, looking for clues to its past life, completely unaware of the magnificent spectacle passing high above their heads. Your trajectory carries you inward, and the next encounter is the big one. This is Earth. The pale blue dot. From a distance, it's a swirl of white clouds over a deep blue ocean, dotted with the greens and browns of land. It is, without a doubt, the most dynamic and vibrant thing you have ever seen. It radiates energy not just in the visible spectrum, but in radio waves, a constant, chaotic chatter of artificial signals leaking out into space. This is the source of all that fuss, the home of the clever little beings who gave you your name, probably something unglamorous like C/2023P1, and who are, at this very moment, pointing every telescope they have in your direction. For them, your arrival is a once-in-a-generation event. You become a fixture in their night sky, a ghostly, glowing streak moving slowly against the backdrop of the stars. Amateur astronomers set up tripods in their backyards, children are kept up late to catch a glimpse, and scientists work around the clock, analyzing the light from your coma and tail to decipher your chemical secrets. They are trying to read you like a book, a pristine manuscript from the earliest days of the solar system. Here's a major scientific debate you're right in the middle of. Did comets like you deliver water and the building blocks of life to the early Earth? Your body is rich in water ice and complex organic molecules. Billions of years ago, during a period called the Late Heavy Bombardment, countless objects like you rained down upon the inner planets. It's a tantalizing idea that the water in Earth's oceans and the carbon-based molecules that eventually formed life were, in part, a special delivery from the frozen depths of space. The chemical signatures of water in some comets match Earth's water very closely, while others don't. The science is far from settled, but as you grace Earth's skies, you are a beautiful, living argument for the interconnectedness of the cosmos. You pass by Earth's moon, a silent, pockmarked sentinel. It's a stark contrast to the living world it orbits, gray, silent, and unchanging, a perfect record of the violent history of impacts in this neighborhood. Next up, you swing past Venus. If Earth is the jewel of the inner solar system, Venus is the cautionary tale. It's about the same size as Earth, its sister planet, but that's where the similarity ends. Venus is shrouded in a thick, yellowish blanket of sulfuric acid clouds. You can't see its surface at all. And that's probably for the best, because the surface of Venus is a true vision of hell. The atmospheric pressure is 90 times that of Earth's, and the temperature is hot enough to melt lead, a scorching 465 degrees Celsius. This is due to a runaway greenhouse effect. Its incredibly thick carbon dioxide atmosphere traps the sun's heat with terrifying efficiency. Venus is what happens when a planet's climate goes horribly, irrevocably wrong. As you fly by, the sun's heat is becoming truly intense. Your nucleus, the solid core of you, is now a hive of activity. Jets of gas and dust are erupting violently from fissures on your sunlit side, creating spectacular plumes. These jets act like tiny rocket thrusters, subtly altering your path. Your motion is no longer governed by gravity alone, you are now a living, breathing, outgassing object, actively shaping your own destiny. You are now at your most brilliant, your most magnificent. But you are also dying. Every gram of gas and dust you shed is a part of you that is lost forever, blown away by the solar wind. You are trading your very substance for this brief, glorious moment in the sun. And the closest, most intense part of that moment is just ahead. You have now passed all the planets on your inbound journey. The inner solar system, once a distant, abstract concept, is now your reality. And the sun, that once distant pinprick of light that guided your million-year fall, is no longer a star. It is a monstrous, terrifying, and magnificent furnace that dominates your entire existence. It fills your view, a roiling, churning ball of incandescent plasma, its surface scarred by sunspots larger than the Earth and lashed by colossal arcs of magnetic fire called solar prominences. The heat is unimaginable. The radiation is a physical force. Your nucleus, the small, solid body at your core, is under siege. The surface is a chaotic landscape of erupting geysers. The ice, stable for billions of years in the deep freeze of the Oort Cloud, is now sublimating at a furious rate. Water, carbon dioxide, methane, ammonia, all the frozen gases that make you are boiling off into space, carrying with them tons of dust and rock every second. You are shedding mass at an astonishing rate, a cosmic ice cube melting in a blast furnace. You are approaching perihelion, the point in your orbit where you are closest to the sun. This is the climax of your entire journey, the tightest turn on your eons-long racetrack. For a few frantic hours, you will be closer to the sun than the innermost planet, Mercury. Your speed is now truly mind-boggling, peaking at hundreds of kilometers per second. You are a gravitational cannonball, whipping around the sun with incredible violence. Your tails are at their most spectacular. The dust tail, broad and curved, now stretches for over 100 million kilometers, a luminous, ghostly scythe across the solar system. The ion tail, straight and blue, points directly away from the sun like a cosmic windsock, a glowing testament to the power of the solar wind. For the briefest of moments, you are one of the largest objects in the solar system, if measured by the sheer volume your tails occupy. But this glory comes at a tremendous cost. The intense gravitational forces from the sun, known as tidal forces, are trying to tear you apart. The side of you facing the sun is being pulled much more strongly than the side facing away. Your small, lumpy body is under immense strain. Many of your cometary cousins don't survive this moment. They are sun-grazers that get too close and either completely disintegrate into a cloud of dust or plunge directly into the sun, ending their journey in a final, silent flash. This is a point of real uncertainty for the astronomers watching you from Earth. Will your nucleus hold together? The structural integrity of a comet's nucleus is one of the great unknowns. They are thought to be fragile, loosely packed agglomerations of ice and rock, sometimes described as fluffy. Some are stronger than others, but it's impossible to know for sure until the moment of truth. You are essentially a cosmic stress test, and failure means obliteration. But you are a survivor. Your nucleus, though groaning under the strain, holds. You whip around the sun in a breathtaking gravitational maneuver. You reach perihelion, the point of maximum speed, maximum heat, and maximum danger. And then, just as quickly as you arrived, you begin to pull away. You have made the turn. You are now on the outbound leg of your journey. The sun's gravity, which spent 1,000,000 years pulling you in, is now acting as a brake. But your momentum is so immense that you are shot back out into the solar system like a stone from a slingshot. Your journey back to the cold and the dark has begun. As you recede from the sun, the heat subsides. The furious outgassing slows to a fizz, and then to a whisper. Your magnificent tails begin to fade, the dust and gas dispersing into the interplanetary medium. You pass the orbits of the inner planets again, but this time you are a diminishing spectacle, a fading celebrity leaving the party. You cross the asteroid belt once more, silent and inert. You pass the great gas giants, Jupiter and Saturn, their gravitational influence giving you a final, gentle nudge on your way out. You pass Uranus and Neptune, the silent, blue sentinels of the outer darkness. The sun shrinks back from a disk to a brilliant star, and then to just the brightest star in the sky. The warmth fades completely. The last of your coma freezes back onto your surface, sealing you once more in a shell of ice. You are becoming a lumpy, inert, and unimpressive rock again. The journey back to the Oort Cloud will take another 1,000,000 years, or perhaps longer. Your orbit has been changed by your passage, by the outgassing and the gravitational nudges from the planets. You may return in 2,000,000 years, or you may be ejected from the solar system entirely, destined to drift through interstellar space for eternity. But for now, you are simply heading home. Back to the profound, silent cold. Back to the stillness and the dark. Your long, eventful, and ultimately very tiring commute is over. The glow has faded, and the silence of deep space welcomes you back like an old friend. The stars, once again, become fixed and unchanging points of light in the eternal, quiet dark. And so, your journey winds down. The brief, fiery crescendo of your life gives way to the long, slow rhythm of the cosmos. The sun, once a roaring giant, is now just a memory of warmth, a bright beacon shrinking in your wake. The planets, those busy, colorful worlds, fade back into star-like points, their dramas and complexities lost to the immense distance. You are on the long road home, back to the quiet, back to the cold. Your mind, which has been racing alongside this icy wanderer, can now begin to slow. Feel the pull of gravity recede, replaced by a gentle, weightless drift. The frantic energy of perihelion dissolves into a deep, cosmic calm. There are no more landmarks to watch for, no more dangers to navigate. There is only the slow, patient journey outward, into the deep and peaceful dark. The story is over, but the drift continues. Let the gentle motion carry you, further and further away from the noise, from the light, into the soft, quiet blackness of a comfortable sleep. The stars will keep their silent watch. The universe will continue its endless, silent dance. And you can just, let go. Drifting now, in the quiet currents of the night, carried on a gentle tide of sleep, toward your own peaceful, silent dawn.